Hi everyone, I'm Gary. Welcome back to Investment Pill. Today we're covering a company most people have never heard of, but whose technology is inside every smartphone, every AI chip, and every cutting-edge computer on Earth. A Dutch company that builds machines so complex and so expensive they might be the most remarkable manufactured objects ever created. Today, we're talking about ASML. We'll cover where they started, the 20-year bet that nearly broke them, how they actually make money, and what the numbers look like today. And as always, nothing here is financial advice. We're here to understand the business together. What you do with that knowledge is entirely up to you. All right, let's get into it. Picture a machine. It costs more than a Boeing 737, weighs as much as 4 double-decker buses, takes a full year to build, needs a specialist team just to install, and requires conditions more sterile than a hospital operating room to run. And there is only one company on Earth that can make it, not one that's better at it, not one with a bigger market share. One company, full stop, no backup. No alternatives. If you want one of these machines, and if you're building a cutting-edge chip, you absolutely need one, you call ASML, or you simply don't build the chip. Every AI chip powering ChatGPT, every iPhone processor, every NVIDIA GPU, they all started their lives on an ASML machine. So how did a company most people have never heard of become the most essential link in the entire global technology chain? And keep this question in your head as we go. Why did their 3 biggest customers, fierce rivals who compete against each other for billions, once pool their money together to essentially rescue ASML and keep it alive? That answer tells you everything. Let's go back to 1984. April 1st, to be exact. And no, that's not a joke. A tiny startup launches in Eindhoven, Netherlands. It's a joint venture between Philips, the Dutch electronics giant, and a semiconductor equipment firm called ASM International. They named it ASML. The early years were rough, like nearly didn't make it rough. They were a small team trying to compete against much bigger, better-funded rivals from Japan. Nikon and Canon, yes, the camera companies, were the kings of the industry, building the machines that printed circuits onto silicon chips. ASML was an underdog, scrapping for every customer. But they kept going. They iterated. They invested when competitors weren't. By 1995, they had enough momentum to go public on the Nasdaq and the Amsterdam Stock Exchange. In 2001, they acquired Silicon Valley Group, their last serious Western rival, and became the global leader in their market almost overnight. But the move that truly defined ASML happened 4 years earlier, in 1997. Their engineers looked at where chip technology was heading and saw a wall coming. The way chips were being made, using a type of light called deep ultraviolet, was about to hit a physical limit. To build the chips of the future, you'd need a completely different kind of light, extreme ultraviolet, EUV. EUV light has a wavelength so short it's absorbed by almost everything, including air itself. Generating it means firing a laser at a stream of liquid tin droplets, creating a plasma that briefly burns hotter than the surface of the sun. The mirrors inside the machine have to be among the smoothest, most precise surfaces ever manufactured. ASML looked at all of that and said, "We're going to do this." The development was brutal. Costs were astronomical, timelines slipped. The project dragged on for years, decades, and this is exactly where our open loop closes. This is why, in 2012, Intel, TSMC, and Samsung all bought stakes in ASML. Intel alone put in $4.1 billion for a 15% stake. three fierce competitors making the same calculation. ASML has to survive, because if EUV fails, our chip roadmaps fail with it. The first production-ready EUV machine finally shipped in 2017, 20 years after the bet was placed. And then AI happened, and suddenly the world couldn't get enough of them. So how does ASML actually make money? At its core, they build lithography systems, machines that use light to print microscopic patterns onto silicon wafers. Those patterns become the transistors and circuits that make chips work. The more precise the machine, the smaller the transistors, the more powerful the chip. ASML makes two main types. First, DUV, deep ultraviolet, their older, established platform. It's the workhorse, and ASML controls about 90% of the advanced market for these. Then there's EUV, extreme ultraviolet, the machine born from that 20-year bet. Every cutting-edge chip, sub-3 nanometer logic, AI accelerators, the most advanced memory, needs EUV, and ASML holds 100% of this market. Zero competitors, none on the horizon. The price tags are genuinely hard to believe. A standard leading-edge EUV scanner runs around 185 to 200 million euros. Each one. Their newest generation, called high-NA EUV, goes for over 350 million euros per unit. A brand new Boeing 737 costs roughly $100 million. ASML's top-end machine is 3 to 4 times more expensive. But here's what makes this business model genuinely special, and why customers can't just walk away after a purchase. Once you bring an ASML machine into your factory, you're basically committed. Installation takes 6 to 12 months of meticulous calibration. The settings that tell the machine how to operate are tuned to that specific machine, in that specific fab, for that specific process. Switching vendors isn't just expensive, it's nearly impossible without halting production. So, ASML doesn't just earn money once per machine. They earn money for the life of every machine they've ever shipped. Service contracts, software upgrades, hardware tweaks that squeeze more performance out of existing tools, all sold back to the same customers, year after year. ASML calls this their installed base management business, and it's now 25% of total revenue and growing faster than anything else they do. The competitive moat, the barrier that stops anyone from copying this, is almost absurd. The EUV light source comes from a company called Cymer, which ASML acquired in 2013. The precision optics inside each machine, built exclusively by Carl Zeiss in Germany, where ASML holds a stake. Every critical component is either built in-house or locked up through exclusive deals. Nikon and Canon are the only other companies in this industry at all. Nikon's entire annual revenue is around $4.8 billion. ASML's is more than 6 times that, and the gap isn't narrowing, it's widening. Let's look at the numbers, and I promise to keep this tight. In 2025, ASML brought in 32.7 billion euros in total revenue, a 16% jump from the year before. To put that in perspective, 32 billion euros is larger than the entire annual economic output of many countries. From a company that builds machines most people have never heard of. Gross margin came in at 52.8%. In plain English, for every 100 euros ASML earns, they keep about 53 euros after paying what it costs to build their product. That's exceptional for any hardware company. Most equipment competitors operate well below that. Then there's that service business, the installed base management we just talked about. It grew 26% last year, faster than anything else in the portfolio. And it makes sense. Every machine they've ever shipped keeps generating revenue indefinitely. The bigger the global fleet gets, the bigger this income stream grows, automatically. You sell the machine once, you collect for decades. The big thing to watch, in 2025, roughly 33% of ASML's revenue came from China. But export restrictions, government rules from the Netherlands and the United States limiting what advanced technology can be sold there, have progressively closed off that market. Management expects China's share to fall from around 33% to about 20% in 2026. The real test over the next couple of years is whether customers in Taiwan, South Korea, the US, and Europe can absorb that gap. Early signals look encouraging, but this is the number to track every quarter. Here's the thing about ASML that I genuinely find hard to wrap my head around. This isn't a company that's one of the best at what it does. It's a company that spent 20 years building something so technically difficult that nobody else on Earth could pull it off. And in doing so, quietly made itself a mandatory checkpoint in the production of nearly every advanced chip on the planet. No ASML machine, no cutting-edge chip. No cutting-edge chip, no next-generation AI. You get the picture. But what I find most interesting isn't the monopoly itself. It's how they got there, the patience, the discipline, the willingness to make a 20-year bet on a technology that didn't yet exist and survive long enough to see it through. That's a kind of corporate behavior most companies are completely incapable of. Understanding why a business ends up in that position, what decisions, what bets, what discipline it took to get there, is honestly one of the most valuable things you can study about any company, whether you ever invest in them or not. Just a reminder, nothing in this video is financial advice. We're here to learn about businesses together, not tell you what to do with your money. Always do your own research. We'll see you next time.